Thanks for watching this screencast. This is a review of learning targets 10 through 12. So for each of the slides you're going to see in this screencast, you have the matching slide on your handout. And what I'll ask you to do at the beginning of each of the slides is for you to pause the video, try the items on the page, and then hit play to get some feedback. So find this first slide, hit pause, try these items, and then hit play to get some feedback. Our goal on each of these problems is to solve for x. We're trying to get x by itself in each of the items. And each of these works a little bit differently. On A, you've got x minus 4y equals 7. And all you really need to do to get x by itself is to add 4y to both sides. I want to remind you that you do not need to, in fact, not only do you not need to, you can't combine 7 and 4y. They're not like terms. You can't write 11, you can't write 11y. You just got to write what's there, 7 plus 4y. And you know you're finished when one side of the equation says only the variable you've been asked to solve for. So the solution to A is x equals 7 plus 4y. B is more involved. In fact, it's probably the most involved of the three. To get x by itself, the first thing I need to do is take my 2y term and move it to the other side and change its sign. Don't lose this negative here. Negative x equals 10 minus 2y. So the last step here is you need to divide by this, and this really means negative 1. So I'll divide the whole right side of the equation by negative 1 as well. And I'll get x equals, there's nothing wrong for this learning target with you writing x equals 10 minus 2y all divided by negative 1. C, if I want to solve 2x minus 10y equals 4, first thing I need to do is make this a positive 10y on the right side of the equation. So what I have is 2x equals 4 plus 10y. And then now I need to divide both sides by 2 because I don't want 2x, I want just x. So an answer not unlike 4 plus 10y all over 2 is acceptable. Okay, on the next slide you've got 4 function graphs that all have time as the independent variable and speed as the dependent variable. And your job is to match which 4 descriptions, A, B, C, D, little a, B, C, D, match the graphs, big A, B, C, D. So hit pause, see if you can match them up, and then hit play. Lowercase a says you increase your speed, then ride at a constant speed along a bike path. You then slow down until you reach your friend's house. That is graph C. You increase your speed increases. Then ride at a constant speed. There's a time when your speed isn't changing. You then slow down until you reach your friend's house. That's C. Lowercase b says you increase your speed, then go down a hill. You then quickly come to a stop at an intersection. That's graph capital A. That's lowercase b right there. You increase your speed, then go down a hill. And what happens when you go down a hill? Well, your speed gets even faster. You then quickly come to a stop at an intersection. In a very short amount of time, your speed goes from being quite a bit to 0. Lowercase c says you increase your speed, then stop at a store for a couple of minutes. You then continue to ride, increasing your speed. That's graph D. You increase your speed, then stop at a store for a couple of minutes. You know, to stop at the store, you have to slow down all the way to 0 first. For the 2 minutes or so you're at the store, your speed is 0. You're not moving. You then continue to ride, increasing your speed. Alright, lowercase d says you ride at a constant speed, then go up a hill. Once on top of the hill, you increase your speed. That's B. Let's see if we can figure out why. You ride at a constant speed. For the first part of the story, your speed isn't changing. When you go up a hill, your speed becomes less. It's harder to go uphill. Gravity's fighting against you. Once on top of the hill right here, you increase your speed. Downhill is easier. And there's the match. Okay, the third slide has these items here. It says on your whiteboard, but you don't have a whiteboard. Just do it here on the handout. Hit pause, try them, and then hit play. This graph is showing the number of cups of flour needed, or excuse me, the number of cups of flour you have remaining after you've baked this many batches of cookies. So what's the independent variable? Well, the independent variable is the number of batches of cookies, because that's the thing that changes the amount of flour you have left. So the number of batches of cookies. And what's the dependent variable? What's the thing that changes as the number of batches of cookies changes? Well, it's the number of cups of flour. Any graph that's been made correctly should have the independent variable on the horizontal axis and the dependent variable on the vertical axis. B says, after how many batches of cookies will there be 5 cups of flour? So 5 cups of flour, we need to figure out where 5 cups of flour is. I see 4 here, I see 8 here. This halfway between there must be 6. So I'm really looking halfway between these two, the ends of each square on the vertical axis. So 5 cups of flour is right there. How many batches of cookies is that? Well, it's hard to tell exactly. It's certainly more than 6. It's less than 8. Would I take 7? Sure. In fact, I think you could argue that it would be weird to say I made less than a whole number of batches of cookies. I suppose you don't necessarily have to make a whole batch. If you told me 7.5, I would buy that as well. Look at C. How many cups of flour are needed to make 8 batches of cookies? Well, that's right here, isn't it? So I'm asking about this point right here, and I think that's pretty clear. That's 4 cups of flour left. Ooh, this is a trickier question than I thought. After 8 batches of cookies, I have 4 cups of flour remaining. So how many cups of flour did I use? I started with 20. I have 4 left. It must have taken 16 cups of flour. Okay, on this slide you've got 6 relations to look at. 3 of them are written as mappings, 2 of them are written as tables, 1 of them is written as a graph. The question is simply which ones are functions. And before you try it, I will tell you that 4 of them are functions and 2 are not. Hit pause and see if you can figure out which ones are which. It might be easier to tell which ones are not functions. We're looking for relations where there's at least one x value that has more than one y. Here's one right here. This one here is not. The one on the bottom right. And it's because of these 2 rows. In this relation, if x equals 4, I don't know if y is supposed to be 7 or if y is supposed to be 14. This is not a predictable machine. So this one is not a function. Where's the other one? It's here. It's the very first mapping. And the issue is with x equals 0, because x equals 0 goes to both 10 and 20. The other 4 are functions. In this mapping, I know where every x goes. Every x goes to only one y. There's no x that has multiple y's that go with it. And even for that's true, it's okay that these 2 x's go to the same y and that these 2 x's go to the same y. I just know where every x goes for its outcome. This table has no repeating x's, so every x has only one y. This graph passes that vertical line test. Anywhere you might draw a vertical line, any x value you pick, that line that you draw vertically is only going to cross it once. There's only one y for every x. Okay, on the last slide on your practice handout, there are two algebraic function rules. Let f of x be 2x minus x squared. Let g of x be negative x squared plus 5. Find these two function values. Hit pause, try it, and then hit play. Okay, to find f of 3, I need to take the rule for function f, 2x minus x squared, and everywhere that I see x, I need to replace x with 3. So I've got 2 times 3 minus 3 squared. And now I need to simplify the right-hand side with order of operations. I should do the exponent next. So I've got 2 times 3 minus whatever 3 squared is, which is 9. And make sure you don't square the negative also. This is 2 times 3 minus whatever 3 squared is. So it's 2 times 3 minus 9. 2 times 3 is next. It's 6. 6 minus 9 gives me negative 3. F of 3 should be negative 3. For g of negative 4, I need to take rule for function g, and everywhere I see x, only right here, put negative 4. Be careful. G of negative 4 says give me the opposite of negative 4 squared plus 5. There's a very common thing that students will do wrong here. Be very careful with your order of operations. The next thing to do is the exponent, but the only thing being squared is the negative 4, not this negative also. Read this like the opposite of this squared. So the opposite of negative 4 squared is 16. And now negative 16 plus 5 is negative 9. So g of negative 4 is negative 9. You've made it through the practice. It's time for you to work on the mastery assessment now. Good luck.